Welcome to the video lecture series of Engineering Mathematics 3. In this lecture, we are going to discuss very important topic of Engineering Mathematics 3, that is vector calculus. Calculus part we have done in previous years, differentiation, integration, limits, continuity. That is coming under the calculus. The calculus of the vector we are going to study. In almost all the programs of engineering, concepts of vector calculus are highly used. If we talk about the electrical engineering, electronics engineering, everything is directly, indirectly related with the current. And current is a vector quantity because it has a direction as well as magnitude. In civil engineering also, various type of forces you have to deal with, and all those forces are the vectors because force has direction as well as magnitude. In mechanical engineering, the mechanical engineers, they are always dealing with the directions. In fluid mechanics, in strength of material, in mechanics of material, the vectors are highly used. In other branches also, even in computer and information technology, the vectors are highly used because the flow of the signals related to the vectors. In this lecture, we are going to discuss the preliminaries of vector calculus. So what is a vector? A vector is any quantity which has direction as well as magnitude, that's all. A quantity which has magnitude as well as direction is called a vector quantity. The velocity is a vector quantity. Force is a vector quantity. Displacement is a vector quantity. These are the vector quantity because it has direction as well as magnitude. Scalar quantity. In scalar quantity, it is a quantity which has only magnitude. Is called a scalar quantity. Is for example, distance is a vector quantity. Anybody asks you what is time now? So it is 9:45. So the direction is not required. Direction is not required. The time is a scalar quantity. Mass is also a scalar quantity. Now, what is my vector point function? A vector function, any vector function, a vector function which varies point to point in a space is called vector point function. This r bar is the radius vector from origin to any point of the space, means xi plus yj plus zk. So this is the vector function. But is it a point function? Yes, because this vector varies point to point. And similarly, the scalar point function, the same thing I am going to write. A scalar function which varies point to point in a space is called scalar point function. So I am denoting scalar point function by phi, writing like this 3x square y z. Since this has no unit vector, means ij are absent. So this is scalar function. But this function varies point to point in the space. See, at this point, value of phi will be what? 3 multiplied by 1 square, multiplied by 2, multiplied by 3 cube. The value of phi at this point is what? 3 multiplied by minus 1 square, multiplied by 3, multiplied by 4, raised to power 3. This is scalar point function, this is vector point function. Just you keep in your mind, whenever ij, k are present, it is a vector function. Now, coming to very elementary concept, that is a dot product. Dot product of two vectors, a bar and b bar. This is a bar and this vector is b bar. Theta is the angle between these two vectors. Then a bar dot b bar is the magnitude of a bar, magnitude of the vector a bar, magnitude of the vector b bar, and this multiplied by cosine of angle between two vectors. Cosine of angle between two vectors. When you take the dot of two vectors, the third thing we are getting, that is the scalar. Now, vector or cross product of two vectors. So how it is resolved? That is the magnitude of a bar. Magnitude of a bar is a scalar. Magnitude of b bar is a scalar. And sine of angle between two vectors a bar and b bar is multiplied by sine of angle between a bar and b bar. A bar and b bar are two vectors. And the important thing is that multiplied by ordinary multiplication, multiplied by n cap. N cap is what? It is a unit vector along a bar cross b bar. This vector is b bar, this is angle theta between two vectors a bar and b bar. A bar cross b bar is perpendicular to the plane of a bar and b bar. is when you take cross product of two vectors. This is vector A bar, red vector. This is vector B bar. When you take cross product of two vectors, the third vector you are getting, and this third vector is perpendicular to A bar and B bar. What is n bar? N cap? N cap is what? N cap is a unit vector along A bar cross B bar, where n cap is the unit vector along A bar cross B bar. Now we are going to discuss vector cross product, vector dot product for three vectors, or we can say vector triple product, scalar triple product. The A bar is a vector, B bar is a vector, and C bar is third vector. Here in scalar triple product also, A bar, B bar and C bar are three vectors. Now what is vector triple product? The vector triple product is A bar cross B bar cross C bar is a vector triple product. Means cross product of three vectors in short. And what is being happened here? A bar is a vector and B bar cross C bar, this B bar and C bar are two vectors, and with the cross of B bar and C bar you get third vector. That third vector cross A bar is complete vector triple product. Here in scalar triple product, A bar dot B bar cross C bar. See the difference between scalar triple product and vector triple product. Here we have cross, here we have dot. The vector triple product can be resolved in this way. In the bracket, in this bracket there are two vectors. The first vector I am going to take here multiplied by, there is no sign, means multiplication, ordinary multiplication. First vector B bar multiplied by dot of remaining two minus next vector multiplied by dot of remaining two. Okay, and the dot product is commutative, is it? Means A bar dot B bar is B bar dot A bar. In this way, the cross product of three vectors can be resolved. Scalar triple product is what? A bar dot B bar cross C bar. This can be written as, I start from this scalar triple product is started from A bar. I am going to start from B bar. After B bar, C bar is there. And after C bar, A bar is there. The dot and cross I had to put, that's all. This is again same as this one. Scalar triple product of three vectors. This can be written as, now I am going to start from C bar. After C, A is there. And after A, B is there. And the dot cross. Okay, meaning of all these three things are same. Now the component wise. If A bar is A1i, A2j, A3k, vector A bar, vector B bar is B1i, B2j, B3k, and C bar is C1i, C2j, C3k. Okay, in terms of component I have written these three vectors. The three vectors are given like this. Then A bar dot B bar cross C bar is scalar triple product. Okay, this can be written in this way also. The box product. This is a fashion of writing only. You are free to use anything. Means A bar space B bar space C bar. If the vector A bar, B bar, C bar are given in terms of component ijk means, so how do you find value of scalar triple product? Using determinant A bar coefficients of ijk. Here A comes first, then B bar is coming, coefficients of ijk from B bar and coefficients of ijk from C bar. In this way you can find scalar triple product of three vectors. Now the gradient of scalar point function. What is gradient of scalar point function? And it is denoted as this del phi. The gradient is denoted like this. Del phi is what I del phi by del x plus j del phi by del y plus k del phi by del z. This is gradient of scalar point function. Phi is a scalar point function, but if you take gradient of phi, the ijk's are present. It is a vector point function. In short, when you take gradient of scalar point function, you get vector point function. Now, the next operator is divergence of vector point function. Okay, and vector point function I am denoting it by f bar. And once you take the gradient, you get vector point function. Okay, this is important. Now, divergence is always taken over vector point function. Divergence of scalar point function is invalid. Let f bar is equal to, f bar is a scalar point function. In terms of component I am writing f1i, f2j, f3k. Divergence of f bar, in short, you can write like this. div of f bar means divergence of f bar, or it can be written, you can write like this also, del dot of f bar. Simply del is gradient, del dot is divergence. The del dot of f bar, how do you find? Del x is partial derivative with respect to x of f1, coefficient of I, plus del f2 by del y, plus del f3 by del z. See, if you look at it very carefully, this is vector point function. See, f bar is a vector point function and ijk are present. But when you take divergence of vector point function, then you get scalar point function. Here you don't find ijk. Here, in short I am writing, when you take divergence of div or del dot of vector point function, you get scalar point function. Okay, this you remember. Divergence of vector point function is a scalar point function. Gradient of scalar point function is a vector point function. And divergence is always taken over vector point function, and gradient is always taken over scalar point function. Now the third operator is a curve. And one more thing I would like to tell you, that del is what? Del is operator. It is a differential operator which has direction. This del is what? I, derivative with respect to x means partial derivative, j, derivative with respect to y, k, derivative with respect to z. If you put this value here and have the dot product, you will be getting like this. Next operator is a curl operator. Curl of vector point function. Curl is always taken over vector point function. Now vector point function I am denoting it by, I am using f bar, and f bar is f1i, f2j, f3k. Del cross f bar is curl of f bar. Or you can write like this, curl of f bar. Del cross is curl, del dot is divergence, and simply del is gradient. Now del cross f bar can be calculated using determinant. As I told you, ijk is the first row of the determinant, and del is what? Del I del x plus j del y plus k del z is del x, del y, del z, and del cross f bar I am taking. F bar is what? Component wise f1 coefficient of I, coefficient of j, and coefficient of k. Gradient, divergence, and curl. The simple sum we are going to discuss. Find the gradient of scalar point function x, y square, z at the point 1, 2, 3. I am going to let this scalar point function by phi, let phi equals x, y square, z. See, gradient of phi is what? I del phi by del x, j del y plus k del del z of x y square z. Means we are finding gradient of this scalar point function. Now take partial derivative very carefully. Derivative with respect to x keeping yz constant. Derivative of x with respect to x is 1 and y square z is multiplicative constant j. Derivative of xy square z means xz are multiplicative constant. Partial derivative with respect to y means what? Derivative with respect to y keeping xz constant, keeping other variable constant. See here, derivative with respect to x keeping other variable means y and z constant, y square z constant, and derivative of x with respect to x is 1. Here x and z constant, derivative of y square is 2z. Okay, I am writing here 2 like this and z. Otherwise you will be in confusion. What is z and what is 2? Plus k multiplied by, take derivative with respect to z keeping xy constant. See, x, y square are multiplicative constant and derivative of z with respect to z is 1. So this is gradient of phi. This is what? Gradient of phi. Phi is given and this is gradient of phi. But here gradient of phi I have to find at this point 1, 2, 3. So gradient of phi at the point 1, 2, 3 at any point. Here at this point I want. In this way I have it. Gradient of phi at this point means what? I am writing directly. See, put x equal to 1, y equal to 2 and z equal to 3. If you put y equal to 2, 2 square means 4, 4 into 3 is 12, 12i plus j. Here put x equal to 1, z equal to 2, z equal to 3 and this z equal to 3. Means 3 into 2, 6, 6 into 3, 18, 18 into 1 is what? 18. Here put x equal to 1 and y equal to 2. Means 2 square is 4, 4 into 1 is. So this is gradient of xy square z at the point 1, 2, 3. This is gradient in general. This is gradient particularly at this point. Gradient of any scalar point function is what gives us the normal direction. This is the surface phi and this surface is a scalar point function, and the gradient of this surface, gradient of this phi, this is phi at this point 1, 2, 3. Gradient of phi is this paper, phi is this surface. At the point 1, 2, 3 is a normal to the surface at that point. This pane, this blue pane is what? Gradient of phi. In this way we have found the gradient of scalar point function. Now we will calculate the divergence and curl of function. Very simple example I am taking. Find the divergence and curl of scalar point, vector point function. This vector point function I am taking. Okay, this is the standard position vector from any point in the space from origin. I want divergence of this vector point function and curl of vector point function. See, here I, j, k are present, therefore it is vector point function, and x, y, z are also there. I am going to find out the divergence. So how to get the divergence? Divergence means del dot. Del dot is a divergence. div of, in this way you can write, but no need to write every time both of this. Divergence of r by how to get? Del del x, partial derivative with respect to x of coefficient of I plus partial derivative of coefficient of j and partial derivative of coefficient of k. There may be any coefficients of ij. Derivative of x with respect to x is 1. Derivative of y with respect to y is 1. Derivative of z with respect to z is 1. So 1 plus 1 plus 1 is 3. Means del dot r bar means divergence of r bar is what? 3. Del dot r bar is 3 and divergence of any vector point function is a scalar point function. Del cross r bar Del cross r bar means curl of r bar. Curl of any vector point function. How do you calculate it? Using determinant. Ijk is common, first row is common all the time when you are finding curl, and next row is always same when you find curl, and we are finding curl of r bar. Then take coefficients of ijk from r bar, x, y and z. Okay. Now try to solve this determinant I in bracket. Write on the minor of I, leave this column and row, del y of z. You can write directly also, I am writing indirectly. Leave this row and column, del y of z and del z of y. When you resolve determinant, the second element minus n by default. Minor of j is what? Leave this column and row, del x of z minus del z of x plus k. Minor of k, leave this column and row, del x of y minus del y of x. Now, del y means partial derivative with respect to y. Partial derivative with respect to y. Keeping other variable, keeping x and z constant. Z is constant, derivative of z with respect to y is 0. This partial derivative with respect to z, keeping xy constant, derivative of constant is 0. Partial derivative with respect to x, keeping yz constant, the derivative of constant with respect to x is 0. Here derivative is 0. Here similarly derivative with respect to x is 0. 0i minus 0j plus 0k. I mean, this is the 0 vector, you can say. Okay, 0 vector, if you write 0 it is okay. You can write 0 bar also. Means curl of r bar is 0. Del dot r bar is 3, curl of r bar is 0. In further calculations, when you solve the problems in vector integration and differentiation, I will directly use this result. Del dot r bar is 3 and del cross r bar is 0. Del dot r bar is 3 and del cross r bar is 0. Now, some expansion formula I am writing. Expansion formula for divergence and curl. See, del dot phi u bar. The first formula, try to understand because many times you have to make use of it. Del cross phi u bar. Del dot means divergence, del cross means curl. Divergence of the product of two scalar point function, vector point function. Curl of the product of two scalar point function and vector point. Here phi is what? It is a scalar point function, and u bar is what? It is a vector point. That's why I did put bar here. Now how to resolve it? Take phi outside, phi del dot u bar plus phi I have taken outside, del dot u bar plus gradient of phi dot u bar. Similarly, del cross phi u bar, just you replace dot by cross, that's all. Del cross u bar, replace dot by cross. So these two expansion formulas are very important when we solve the problems on vector identities. Vector identities means the problem involving del cross, del dot, and r. R is what? R is the magnitude of r bar and magnitude of xi plus yj plus z, and this is what? Under root of x square plus y square plus z square. Magnitude of vector is written like this. Problem involving divergence, curl, gradient and r, function of r, those are called vector identity problem. When we solve vector identity problem, so these two formulae will be highly used. So we stop here. In the next lecture, we will be discussing some problems on directional derivative. Thank you very much.